In this lesson, you will learn about linear equations. The best way to understand linear equations is to look at an example. So in this example, y equals 2x minus 1. The two variables are y and x. And this red line is the line that represents the equation y equals 2x minus 1. On the right, there is a table, just a t-chart, that has different values of x's. And the way the y values were found were just by substituting each of the x's into the equation. So if I take the first one, x equals -2, this column right here, and I substitute it into y equals 2x minus 1, I have y equals 2 times -2 minus 1, which is -4 minus 1, and -4 minus 1 is equal to -5. So the answer that I get in the y row is just the coordinate. So this line has coordinates -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. If I identify those points on the equation, -2, 5 is right here, left 2, down 5, -1, -3 is left 1, down 3, 0, -1, 1, 1, and 2, 3. So these are just 5 of the points that lie on this line, or that are solutions to the linear equation. This equation has other solutions. For example, this point right here lines up with this coordinate of x equals 4 and this coordinate of y equals 7. So to make sure that that's correct, let's take the point 4, 7 and write the linear equation y equals 2x minus 1. And in for x, I'll substitute 4. In for y, I'll substitute 7. So that I have 7 equals 2 times 4 minus 1. And if I simplify this, I get 7 equals 7, which is a check to show that the point 4, 7 is a solution to the linear equation y equals 2x minus 1. Another thing to note about linear equations is that there's different ways that they could be written. One way is to write it in standard form. And standard form is when you have x and y together on one side of the equation and the x is positive. So if I want to change it to function form, that means to solve for y. So the first step in solving for y is to move the x over to the other side by either adding or subtracting. And it cancels, and I'm left with -4y equals 12 and -3x are different terms, so I have to write them separately. I could write them as 12 minus 3x or -3x plus 12. I like to write the x term first because later on when you learn slope-intercept form of a line, you'll have it in the correct form. And the last step in solving for y is to divide everything by -4. So just divide everything by y's coefficient. And when you divide by y's coefficient of -4, the -4 cancel, or the -4's cancel, and we're left with y equals -3 over -4 simplifies to 3 over 4. And then 12 over -4 is -3, so it's just -3. So in function form, it's y equals 3/4 x minus 3. So if a question asks you to use function form, always solve for y. The second example, 2x plus 4y equals -8. To solve for y, start by moving the x term over by either adding or subtracting, so that the x's cancel, and you have 4y equals, I like to write the x term first, and then the constant, and then I divide by y's coefficient. So everything gets divided by positive 4, so that the 4's cancel. Negative 2 over negative 4 reduces to negative 1/2, and then I just place the x next to it. Negative 8 over 4 reduces to negative 2. So the function form of this example is y equals negative 1/2 x minus 2. This next example is a little more complicated because we have the fraction of 1/3, so what I would like to do is get rid of the fraction. And a very simple way to get rid of this fraction is to multiply everything by 3. And if I multiply all of the terms by 3, I have 3 over 3x plus 6y equals negative 3. 3 over 3 is 1, so I'm left with just x plus 6y equals negative 3. So my goal is to still write this in function notation, and all I've done really was clear the fraction, and now I'm ready to pick up the way we did on the last two examples. Always move the x over first by either adding or subtracting. And we get 6y equals, the x's cancel. You want to write the x term first and the constant second. So let's finish this up right here. And I'll copy the problem over. And the last step is to divide by y's coefficient. Always go in that order. Move the x over by adding or subtracting, and then dividing by y's coefficient. And everything gets divided by positive 6. The 6's cancel, so that I have y equals. Keep in mind that there's a negative 1 in front of this x, and negative 1x over 6 is just negative 1/6 x, and then negative 3 over 6 reduces to negative 1/2. So function form is y equals negative 1/6 x minus 1/2. So always solve for y when you're writing an equation in function form. So the only thing I have to do on this example is subtract 4 from both sides, and that gives me y equals negative 3. So the function form is y equals negative 3. For 2y equals 8, the 2 is being multiplied by y, so I divide both sides by 2 and get y equals 4. So function form is y equals 4. For this example, 3x equals 12, it looks like we could divide everything by 3, but when I divide by 3, I am just left with x equals 4. To write an equation in function form, it has to be y equals. Since we don't have a y, this example is not a function, so we cannot write it in function form. So for number 1, determine which ordered pair is a solution of negative 3x plus 4y equals 12. So this is a multiple choice question, and we'll just check each solution one by one, starting with choice A. We'll substitute 1/3 in for x and 4 in for y. So if I take the equation negative 3x, that's negative 3 times 1/3 plus 4y is plus 4 times 4. We want to see if this equals 12. So negative 3 over 1 times 1/3, the 3's cancel, and I'm left with negative 1. And then 4 times 4 is 16, gives me 15, which is not equal to 12. So choice A is wrong. So choice B, now we'll substitute negative 4/3 in for x and 2 in for y. So we have negative 3 times negative 4/3 plus 4 times 2. And now we want to see if this is equal to 12. So we take negative 3 and write it over 1. Negative 3 and 3 cancel to negative 1. Negative 1 times negative 4 is positive 4. 4 times 2 is 8. And 4 and 8 add to 12. So this works. So therefore the answer is B. You can check C and D if you'd like, but once you get a solution you can stop. For number 2, very similar to number 1, but instead of given the equation, now we're given the point. Determine which equation has negative 3, 2 as a solution. So I'll take negative 3, substitute it in for x, 2, substitute it in for y, and stop when I get one of the equations to work. So I have negative 2 times negative 3 plus 4 times 2 equals negative 10. Negative 2 times negative 3 is 6. 4 times 2 is 8. 6 and 8 is 14, not negative 10. So choice A is out. For choice B, 1/3 times negative 3 plus 2 times 2 equals negative 8. And 1/3 times negative 3 is 1/3 times negative 3 over 1. The 3's cancel, and it reduces to negative 1. 2 times 2 is 4. And negative 1 plus 4 is 3, which also does not give us negative 8. And now we check choice C. 2/3 times negative 3 minus 2. And I start by placing negative 3 over 1. The 3's cancel to negative 1. And I have negative 2 minus 2 equals negative 4. Negative 2 minus 2 is negative 4. So choice C is the answer because both sides of the equation are equal when we substitute in the point negative 3, 2. For number 3, find the value of b that makes the ordered pair negative 8b a solution to negative 3x minus 5y equals 11. So very similar to the last two examples, I'm going to place negative 8 in for x and b in for y. And I'm going to take my equation of negative 3x minus 5y equals 11 and substitute negative 8 in for x, b in for y, and I'm going to solve for b. So I get 24 minus 5b equals 11. To solve for b, I start by subtracting 24 from both sides. The 24's cancel, and I'm left with negative 5b equals negative 13. So after I divide by negative 5, I get a final answer of b equals positive 13 over 5. The negatives cancel. I could also write this as 2 3/5, but you don't have to. So this is my value of b, and it means that the point negative 8, 2 3/5 is a point on the line negative 3x minus 5y equals 11. For number 4, the directions are to graph the linear equation. And what I'm going to do for this is I'm going to make a t-chart. And I'm going to pick 3 points. Your teacher may require you to pick more points, but for this example I'm only going to choose 3. And the points I'm going to choose are negative 1, 0, and 1. And I'm going to take each of these x values and just substitute them in for x and solve for y. So that I get 2 plus 4y equals 8. And then I subtract 2 from both sides. I'm just solving the equation to give me 4y equals 6. Divide both sides by 4. And I get y equals 6 over 4. And if I divide both of these numbers by 2, my value of y reduces to 3 over 2, which is 1.5. So underneath negative 1, I'll write 3 over 2. And if I go to my graph, I have the point negative 1, 3 over 2. So I go left 1, down 1.5. Now I do the same thing, but now I substitute 0 in for x. So I have negative 2 times 0 plus 4y equals 8. And negative 2 times 0 is just 0, so I'm left with 4y equals 8. Divide both sides by 4, and y equals 2. So underneath 0, I put the number 2, and my point is 0, 2. And last, I take the number 1, substitute it in for x, and solve for y one last time. So negative 2 plus 4y equals 8. I add 2 to both sides so that the 2's cancel, and I have 4y equals 10. Divide both sides by 4. Y is equal to 10 over 4, which both numbers can be divided by 2, and I get y equals 5 over 2, which is 2.5. So you can write 5 over 2 or 2.5, so that my point is 1, 2.5. So the other 2 points left to graph are 0, 2, and then 1, 2.5. So this point is negative 1, 1.5. Now I do the same thing, but now I place 0 in for x. And I have negative 2 times 0 plus 4y equals 8. Negative 2 times 0 is just 0, so I'm just left with 4y equals 8. Divide both sides by 4, and y is equal to 2. So underneath 0, I put the number 2, and I write the point 0, 2. And last, I take the x-coordinate of 1, substitute it in for x, and solve for y. So I add 2 to both sides, and I get 4y equals 10. I divide both sides by 4 to get y equals 10 over 4. 10 over 4 can be reduced by 2, and that gives me 5 over 2. And 5 over 2 is the same as 2.5. So underneath the 1, I put 2.5, and then I write the point 1, 2.5. So now I go to my graph, and I graph all 3 points. starting with negative 1, 1.5. So I go left 1, up 1.5. And then 0, 2, I just go up 2. And then 1, 2.5, I go right 1, up 2.5. I connect the points, and there's my line. For number 5, to graph this equation, I'm going to use the same method, make a t-chart, but instead of picking the values of negative 1, 0, and 1, I'm going to pick the values of negative 3, 0, and 3. And the reason why I'm picking negative 3 and 3 instead of negative 1 and 0 is because the coefficient of x is a fraction, and the denominator of 3, I wanted to pick numbers that were multiples of 3. This way the math to calculate it is easier. So if I start with x equals negative 3, and I take 1/3 times negative 3 plus y equals negative 1, negative 3 over 1 just reduces 3 and negative 3 to negative 1. So I have negative 1 plus y equals negative 1. And then I add 1 to both sides, and I get y equals 0. Then I do the same thing, but now substituting 0 in for x. 1/3 times 0 is 0, so that just cancels, and I'm left with negative 1. And last, I substitute 3 in for x and solve for y. And 3 I can place over 1. The 3's cancel, and I'm left with just the number 1. And then I subtract 1 from both sides, and I get y equals negative 2. So my 3 points are negative 3, 0, 0, negative 1, 3, negative 2. So negative 3, 0, 0, negative 1, and 3, negative 2. I connect the points, and there's my line. For number 6, y equals negative 3. Now to graph this, it might seem a little odd considering that we don't have any x values to substitute in for, but I'm going to go with negative 1, 0, and 1, and this problem is actually very simple because no matter what my x value is, my y value is always equal to negative 3. So I don't really have to do any work here, but I do want to write the points negative 1, negative 3, 0, negative 3, and 1, negative 3. So if I plot those points, left 1, down 3, and then for 0, negative 3, just down 3, and 1, negative 3, I go right 1, down 3. Notice how these points line up to form a horizontal line. Whenever you are graphing a line, you want to make sure you extend the line past the points that you graphed and place arrows at the end. For number 7, x equals 2. So now when I make a t-chart, I have to put 3 2's in for x. But the only way I could find y would be by picking my own numbers, because x is always equal to 2. So if I went with negative 1, 0, and 1 on my y row, I have the points 2, negative 1, 2, 0, and 2, 1. When I plot these points, 2, negative 1, 2, 0, and 2, 1, these points line up to form a vertical line. For numbers 8 through 10, write the equation in function form and then sketch its graph. So we'll still make a t-table, but what we're going to do first is just change the form so that it's in function form, and that means get the equation so that it's y equals. And when we add 6x over, we have 3y equals 6x plus 3. And the last step in getting this in function form is to divide everything by 3. And I have y equals 2x plus 1. So I make a t-chart with x and y, and I pick 3 values for x, and I substitute -1 in for x using function form. You can use the original form if you'd like, but function form is easier once you have it in that form. And you just evaluate y, and we get y is equal to -1. And then we substitute in 0. So 2 times 0 plus 1. 2 times 0 is 0, and we're left with just the number 1. And then we substitute in 1. 2 times 1 plus 1. So our 3 points are -1, -1, 0, 1, and 1, 3. So -1, -1 means left 1, down 1. 0, 1 is just up 1. And 1, 3 is right 1, up 3. And connect the points to form your line. So for number 9, to get this linear equation in function form, we always start by moving the x term over by either adding or subtracting. And we get 4y equals just -2x. You can put plus 0, but you don't need to. And then we divide by 4, and the 4's cancel, and -2 over 4 reduces to -1/2 x. So now when I make a t-chart, I'm going to change my values so that I have multiples of 2 because 2 is my denominator. So I will go with -2, 0, and 2. So when I start with -2, I have -1/2 times -2, -1 times -1 is 1, and then I substitute in 0, which is just 0, and then I substitute in 2, and they cancel to 1, so that y is equal to -1. So the 3 points that I want to graph are -2, 1, 0, 0, and 2, -1. So -2, 1, I go left 2, up 1, 0, 0 is just the origin, and then 2, -1, connect the points, and place the arrows at the end of the line. And for number 10, 2x minus 3y equals 6, I start by subtracting 2x from both sides so that I'm just left with -3y on the left side of the equation, and then I always want to write the x term first and then the constant. Since 6 was positive, we add 6. And then we divide by y's coefficient of -3. Everything gets divided by -3 so that I just have y equals, and that's now in function form. -2x over -3, the negatives cancel and I have 2/3 x. 6 over -3 is -2, so I have -2. And when I make my t-chart, because my fraction has a denominator of 3, I want multiples of 3. So that would be -3, 0, and +3. So I have y equals 2/3 times -3, and I'll put -3 over 1, minus 2. The 3's cancel, and I have y equals -2 minus 2, which is -4. Then I substitute 0 in for x, and the term cancels, and I'm left with just -2. And then 2/3 times 3 over 1. The 3's cancel, so that I have 2 minus 2, which is just 0. So my 3 points are -3, -4, 0, -2, and 3, 0. So -3, -4 means left 3 and down 4. 0, -2 is just down 2. And 3, 0 is just right 3. Connect your points, and there's your line.